Hello, everyone. Welcome to the first session of 4 Steps to the AI World. We are so happy to have you here, and it's really great. So, this is Saidal together with Hamid, another Microsoft community leader. So, Hamid, yeah, it's time, right?
That's fascinating. That's really great. I'm so excited that we are having our first ever AI session. I mean, not just talking about AI, but this is actually a training session about AI 900. So that's so exciting that now we have this opportunity together with Microsoft Learning Rooms, providing this training bootcamp for 5 sessions. That's amazing.
Yeah, exactly. Actually, it's the fourth session, just to
Okay,
mention,
sorry.
because yeah, we
Yeah,
kind of
4 sessions.
compacted to have kind of aligned it with AI Skills Challenge, and it's really great because we are in AI Skills Challenge month, and if you haven't registered yet, please make sure that you have registered in AI Skills Challenge, and it's really cool. You can learn a lot of things with AI Skills Challenge. So basically as Hamid mentioned, we are going to have 4 sessions with 4 steps to help you to understand the concepts of AI and AI in Azure based on different services. And the main goal is helping you to get into the AI world. So, with that said, we have some other things to share with you. The first of all, at the end of these sessions, we are going to share with you the badge, a specific badge for these sessions called AI Hero Community Learner. But there is some, competition there. You need to answer some questions middle of the sessions, which help you to basically be part of that. And beside that, we have some other things which we are going to share at the end of each session. So we are not going to spend a lot of time here, Hamid. So I'm going to share the screen
Yeah,
and
let's go.
the slides. So let's do it, right?
Ready.
Cool. So let's do it. Perfect. So the first part of the AI. Let's start with the agenda. So today we are going to cover these 3 parts: fundamental AI concepts, fundamental of machine learning, and also fundamentals of AI, Azure AI services. What we are going to learn here is about explaining what is AI and understanding of importance of the responsibility AI, understand the different type of machine learning models, and also identify the AI services available on Azure and what they are used for. So let's start with fundamental AI concept. One thing that I need to mention, maybe some part of these slides or this presentation is not that much maybe at this step understandable for you, but it's no problem. It's all about the concepts, and you need to understand these concepts to be able to understand the complex part of the AI. So we are going to help you to understand that part, and beside that, you need to get into the AI by learning and doing. So don't worry if you miss some part of that, and also you can rewatch these sessions on our YouTube channel. So let's start. uh, what is artificial intelligence? So AI, or artificial intelligence, is the simulation of human intelligence process by machines, especially computer system. It involves the use of algorithms and data to enable machines to simulate human like cognitive functions such as learning, problem solving, perception, and understanding natural language. So now let's break down how AI relates to everyday human activities. First of all is predictions and pattern recognition. So, to just explain it, think of AI like your favorite weather app that predicts the weather based on historical data and current conditions. just like how you can predict a rainy day based on cloudy skies. AI can make predictions and recognize patterns using available information and past experiences. The second of these AI day to day usage is intuition and anomaly detection. Consider AI as the fraud detection system. For example, for your bank that flags unusual transactions, just like how your instincts might tell you that something doesn't quite fit an expected pattern. The other part is visual experience. AI in visual recognition is like the tagging feature on social media that identifies faces in photos. It uses sight to experience the world visually, similarly to how humans use their vision, right? The other one is communication. Chatbot and virtual assistants such as Siri, Alexa are examples of the AI and also AI that engage the dynamics conversation and response appropriately, similar to how humans communicate by writing and speaking, like that. And the last one is information extraction. So AI can be compared to a search engine that extract information from various sources to deliver relevant search result, akin to how humans gather knowledge from multiple resources to extend their understanding of particular topic. So right now, we understand what is AI or artificial intelligence. Now, we need to get understanding of common AI workloads. There are several common AI workloads. So, if I want to explain how does it work, I prefer to go through an example. So, imagine you are chatting with a virtual assistant to file an auto insurance claim, like online insurance, right? When you tell the assistant you want to file a claim, it understands your message through natural language processing, just like how to understand a normal conversation. Then, if you send a photo of your damaged car, it uses computer vision to assess the damage, like of kind of how you identify the damage with your eyes. Okay. After that, it uses machine learning to predict how much the repair will cost based on similar cases from the past. It's like how you estimate how much something will cost based on your various experiences. If the system senses something sketchy about the claim, it uses anomaly detection to flag it as potential fraud claim, just like how you might notice something fishy in a same situation. Finally, it gathers all the information from the claim and creates a searchable database, which is like putting all the like pieces of the information in filing cabinets. So it can be easily found later if you categorize them, if you save them in some like filing cabinet. So this helps in handling future claim more efficiently. All these different tasks overlap and work together to provide a smooth and efficient experience, just like how a team of people with different skills work together to solve a problem. So we learn about common AI workloads, but now the other important part, which is related to principles of responsibility of AI. So If I want to explain it to you, the principles of responsible AI refer to sets of guidelines, ethics, and best practices that aim to govern the development and use of artificial intelligence in a responsible and ethical manner, which is super important. The principles are designed to ensure that AI systems are developed and used in a way that promotes fairness, transparency, accountability, and privacy. For example, imagine a scenario where AI is used to make decisions about loan approvals. In this case, the principles of responsible AI would ensure that the AI system takes into account factors that are fair and non, discriminatory, and basically provides a clear explanation for its decisions and safeguards the privacy of individual and also financial information. In summary, the principles of responsible AI are a framework for ensuring that AI technologies are developed and used in a way that aligns with ethical, legal, and social values. So, there are some part of this principle AI. Just want to explain it a bit more for you. So one of them is fairness. Fairness in AI refers to the principle that AI system should treat all people fairly and without bias. For example, when creating a machine learning model for loan approval that I just explained, it should make predictions without incorporating any base based on gender, ethnicity, or other factor that might result in an unfair advantage or disadvantage to specific groups of applicants. Azure machine learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction, helping data scientists identify and mitigate bias in a model. The other one is reliability and safety. AI systems should perform reliable and safely to avoid substantial risk to human life. Another example, an autonomous vehicle or a machine learning model that diagnoses patient symptoms must be reliable to ensure human safety, correct? AI-based software applications must undergo rigorous testing and development management process to ensure that they work as expected before the release. Another one is privacy and security. AI systems should be ensured that respect privacy, and like machine learning models rely on large volume of data, including like personal detail that must be kept private. And both during training and production, the system should adhere uh, to privacy and security concerns when using new data to make prediction or take actions. Another one is inclusiveness. AI systems should empower everyone and bring benefits to all parts of the society, regardless of physical ability, gender, sexual orientation, or ethnicity, or other factors. And also, we have transparency, which is the AI system should be understandable and users should be fully aware of the purpose of the system, how it works, and what limitations may be expected. And the last one is accountability. People should be accountable for AI system. Designer and developer of AI-based solutions should work within a framework of governance and organizational principles to ensure that the solution meets ethical and legal understands that are clearly defined. So these principles collectively form the foundation for the responsible development and use of AI, ensuring that AI technology align with ethical, legal, and social values. So these two factors related to concept of machine learning and the AI and principle of responsibility are two important concepts that we need to actually know about them. And the next part is about fundamental of machine learning. Actually, we need to understand what is machine learning and somehow how does it work. The information that we are sharing with you from these slides, basically this part of this presentation, a bit maybe complex, but we are trying to explain it with some examples and so on. So what is machine learning? Here, I want to explain it based on some maybe examples. So think of it like this, like an example. You're sorting through a bag of mystery items, and you are trying to figure it out what each item is from its based on shape, size, and color. The goal is to become a master of uh, guessing what everything is. Basically, you can find it, you can understand, you can guess that. Each item you pick up and each item you actually pick up, you look at its different feature like the shape, the size, the color, and decide what is it. Kind of like guessing what is inside a rapid gift by like shake it and weight it, or like based on shape or based on size. The thing you are trying to identify is the label, like the name of the thing. So, and the features you are using to guess are called X in this case. Now there is a secret recipe, or in this case we call it an algorithm, that helps you to get better at guessing. It's like a magical formula or trick that improves your guessing skills each time you use it. This formula turns the features into the guess about the label, just like having a special formula for guessing what's in a wrapped gift based on the shape, size, and so on. After lots of practice, you become a master of guesser. You can be a master guesser, right? And you've mastered a super fancy guessing equation called F in this case that helps you make the best guesses. This equation takes the items features and turns them into a super accurate guess about what the item is. So then, when your friends bring you new mystery items, you can use your fancy formula to guess what's inside without even opening the wrapping. And since it's a prediction based on formula, we call it here y or y hat. So as you can see in this slide, there is a wide right side hand of slide, and there is a kind of symbol on top of that. So we call it y hat in this case. So with this y hat, instead of just basically using regular guess, we are using this method. So, in simple terms, it's like training to become a master guesser with a magical guessing formula, and then using that formula to make the best guess about new mystery items. So, it's the explanation of machine learning, but based on kind of example. So if I want to explain each part of this slide, like item per item, so the first one, left side hand, you have training data. So training data consists of past observations. In most cases, the observations include the observed attributes or features of the thing being observed and the known value of the thing you want to train a model to predict, and we call it we know it as the label. In mathematical terms, you'll often see the features referred to using the shorthand variable name x, and the label referred to as y. Usually, observation consists of multiple feature values. So x is actual a vector. In this case, vector is an array with multiple value, like x1, x2, x3. The other part is the algorithm. So algorithm is applied to the data to try determine a relationship between the features and the label, and generalize the relationship as a calculation that can be performed on x to calculate y. The specific algorithm used depends on the kind of predicts problem you are trying to solve. But the basic principle is to try to fit the data to a function in which the value of the features can be used to calculate the label. And number three, related to model. The result of the algorithm is model that encapsulates the calculation derived by the algorithm as function. So we need to call it f. Basically, we call it f. In mathematical notation, it's like y equal fx. So for the last part, which is related to inferencing data, when we have done with part three, now that the training phase is complete in item 4, the train model can be used for inferencing, and the model is essentially a software program that encapsulates the function produced by the training process. You can input a set of feature values and receive as an output a prediction of the corresponding label, because the output from the model is prediction that was calculated by the function and not an observed value. You will often see the output from the function shown as y hat that I just mentioned. It's the design part of the machine learning and how basically does it work. So I know it's a bit complex now, but maybe you need to read more about these machine learning, and also maybe you need to rewatch this video to understanding better. So when we kind of learn about machine learning, there are types of machine learning, and each part is related to some type of design of AI. So in top of machine learning types, we have two main types, which is supervised and unsupervised. For supervised machine learning, basically is a general term of machine learning algorithm in which the training data includes both features value and known labels value. Supervised machine learning is used to train models by determining a relationship between the features and the labels in past observations, so that unknown label can be predicted for features in future cases. So under supervised machine learning, we have two main parts. One of them is regression. Uh, this one is a form of supervised machine learning in which the label predicted by the model is a numeric value. So, for example, the number of ice creams sold on a given day based on the temperature, rainfall, and wind speed, or the selling price of property based on its size in square meter and the number of bedrooms it contains, and some other economic metrics for its location, or the fuel efficiency of a car based on its engine size, weight, wire, and also height and length. The other part is classification. So, classification is a form of supervised machine learning in which the label represents a categorization or class. There are two common classification scenarios that we have. One of them is binary classification, the other is multi-class classification. So, for binary classification, the label determines whether this observed item and instance of the specific class. So, or put another way, like binary classification models predict one of two mutual exclusive outcome. And if I want to give you some example, like whether a patient is at risk for diabetes based on clinical metrics like weight, age, blood glucose level, and so on, or like whether a bank customer will default on a loan based on income, credit history, age, and other factors, or whether a mailing list customer will respond positively to a marketing offer based on demographic attributes and past purchase. So, in all of these examples, the model predicts a binary, like true, false, or positive, negative prediction for a single possible class. So, how is multi-class classification? Multi-class classification extends binary classification to predict a label that represents one of multiple possible classes. For example, the species of penguin like Adelie, Gento, or chinstrap based on its physical measurement, or the genre of the movie, like comedy, horror, romance, adventure, or sci-fi, based on its cast, like director or budget. In most scenarios that involve a known set of multiple classes, multi-classes classification is used to predict mutually exclusive labels. For example, a penguin can be both in two species, like Gento and Adelie. However, there are also algorithms that you can use to train multi-label actually classification models, in which there may be more than one valid label for a single observation. For example, a movie could potentially be actually categorized as both sci-fi or comedy actually. Let's go through unsupervised machine learning. So, unsupervised machine learning involves training models using data that consists only of future values without any known labels. Unsupervised machine learning algorithms determine relationship between the features of the observations in the training data. In this case, we have one items call it clustering. So the most common form of unsupervised machine learning is clustering. A clustering algorithm identifies similarity between observation based on their feature and groups them into like a cluster. For example, groups similar flowers based on their size, number of leaves, and number of petals, for example. So these are types of machine learning. So since we learned about them, we have the other part, which is related to model training and evaluation. So in this part, we have actually 5 steps for training and evaluation that I'm explaining in briefly each one of them. The first of all is the actually training the data. So it's like splitting the data, as you can see inside the slide. The data is divided into a training set and a validation set. The training set is used to teach the model, which the validation set is used to test the model prediction. And then the item 2, which is applied algorithm and fit the model, and is applied to fit the training data to a model. The model encapsulates the relationship in the data learning form. It's a learning form, the features and the labels in the training set. The item 3 is related to train model encapsulates and the relationship in the data. So after model fitting, the trained model encapsulates the relationship in the data, and this means that the model has learned and internalized the pattern and connections present in the training data, allowing it to make predictions or identify clusters based on this relationship. Uh, so we have the other part, which is prediction or generate predictions. The trained model is used to generate predictions from the validation data, and it means the data uses the relation it has learned from the training data to make predictions on a new unseen data. And this item 5, which is related to evaluations of model, and it's a metric are used to compare the predict label with the actual labels, or to measure cluster separation. So this step helps us to actually see how well the model is predictions match the actual label. And at the end, as you can see the inside the this diagram, it's a kind of repeat. So the process is repeated, and it's a kind of fine tune the model and improve the its accuracy. This repetition is a part of the learning process of machine learning, where adjustments are made to the model over multiple iterations. So next part is about deep learning. So how deep learning does work? I want to split it in 3 parts to explain it a bit more. So for deep learning, the first part I want to kind of explain for you, it's the brainiest stuff. I call it brainiest stuff. So deep learning is like the brainy cuisine of machine learning. It's all about mimicking how our smart brains learn things by using artificial neuronal networks. These networks are like a bunch of brain cells working together in layer, kind of like delicious layered of the cake. So they are kind of connected together, right? The other part that I can explain it to you, it's like a multi-layered magic. So why I call it like this? Because each layer is like a different level of thinking, and when you stack them together, you get a super duper complex way of processing information. It's like having different filter for understanding stuff. This multi-layered magic is why it's called diving deep into understanding things. And the last part, which is called DNN bridge. Uh, Basically, the model created through deep learning, unlike the superheroes of the AI world, known as deep neuronal networks, in short is DNN. They can tackle all sorts of tasks from simple number of crunching or understanding human language and even recognizing object in image. The DNN are the actually rocket star of the tech world, if I want to give it a name. So it's all about the deep learning. How deep learning actually works. Okay, so Uh, to better understand how a deep neuronal network (DNN) model works, let's explore an example in which a neuronal network is used to define a classification model for, like, last example that we had, penguin species. The future data is X consists of some measurement of penguin, especially the measurements are like the length, the dips, the actually different part like the length of penguin flippers, the penguin weight. So the label we are trying to predict is Y in this case, is the species of the penguin, and actually are three possible species it could be. So we have three possible species called Adelaide, Gento, and Chinstab. The process of inferencing a predicted penguin class using the network is: step one, the future vector for a penguin observation is fed into the input layer of the neuronal network, which consists of a neuron for each x value. In this example, for following x vector is used as the input, like 37.3 or like 19.2. The functions, the second part actually, the functions for the first layer of neurons, each calculate a weighted sum by combining the x value and w, which is weight in this case. And the third part is each neuron is a layer is connected to all the neurons in the next layer. So it's a like network. The result of each layer are fed forward through the network until they reach to the output layer. And the level 4 is the output layer produces a vector of value. In this case, using a softmax or similar function to calculate the probability distribution for three possible classes of penguin. In this example, the output vector is, for example, 0.2, 0.1. And the fifth, the elements of the vector represent the probabilities for class 0, 1, and 2. The second value is the highest. So the model predicts that the species of the penguin is 1 or gentle. So the model learns the appropriate weight with initially passing the training data through the evaluating the predict probabilities for each class against the known class label. The weights are adjusted in each iteration, or let's say to reduce the amount of error between the prediction and also the value that represent the actual class label. So it's how NND works in this case. So I think I'm done with slides. So Hamid, I think.
I'm here. Wonderful.
Yeah. Okay. So yeah. I handed over to Hamid to continue with the rest of slides and machine and what is the Azure machine learning.
Perfect, Said. Thank you so much. That was the greatest simplified version of AI, Microsoft AI, and the definitions that I ever see. I really love the way that you also simplified the slides and explaining, because most probably we have people from different backgrounds, and I guess majority also new to Microsoft AI services, that they want to start their learning paths, their career with it. And as you saw, like in the previous slides, so it's all about your data. It's all about statistics. It's all about the analytics, mathematical algorithms that you put them together to make your own AI, so that it can respond to you anytime you ask about something. So it can calculate based on your own custom data and return the result to you. So let's start. So in this slide, it is starting with what is Azure machine learning. But I would like to go first. What is machine learning in general? So you saw that it's all computer programs. It's all mathematics. It's all writing some formulas. So the way also Said explained, I really love this. So it is really simplified also in the slides, that it shows that how you put together some kind of mathematical formulas in order to build your own algorithms. So if you want to say what is machine learning in general as a definition, so yeah, again, it's computer programs that you use to recognize your own pattern and your own data and make predictions again on your own data. So in general, machine learning models, you create them from the algorithms you have or you create based on the mathematical formulas you generate. So that training process actually, you're using your labeling, unlabeled, and mixture of your own data, which also explained in previous slides. So there are different machine learning algorithms, and which are suited for different goals, which again, as mentioned, the classification or predicting different kind of modeling. So data scientists, people with different backgrounds, people in data, they can use different algorithms as the basis for different models. So the data is introduced to a specific algorithm then, and it is modified to better manage a specific task to become a machine learning model at the end. So this is the general definition of the machine learning. So we will have time actually at the end to answer the questions, and we will also have an opportunity to show the actual services within Azure portal. So together with Said in my next slides, in upcoming slides, so we will show you the actual services. So we can actually touch those services within the Azure portal. So if you could, Said, go one slide back, I want to go a little bit on, yeah, great, wonderful. Want to explain a little bit about Azure machine learning. So yeah, now we know what does machine learning do in general. So let's see what are the facilities or benefits of Azure machine learning, because we are in this path on AI 900 course, and we want to start our learning path and career path actually with Azure services, in this case Azure machine learning service. So in general, Azure machine learning is also a cloud service that you can use beside the other services you have, like any other service, IaaS services, PaaS services. So in this case, we have Azure machine learning also as a service. So you use it for training, for deploying and managing your own machine learning models based on your own custom data. So this is also what makes Microsoft unique in AI market. So together with Copilot and Azure AI Services, so the slogan is that you use your own data and you use models as a service to train your own data. So this is actually the greatest part of the Azure machine learning service. So in general, it is designed to be used by data scientists, again, by analytics, software engineers, or DevOps engineers, or professionals with different backgrounds who needs actually to deal with data and machine learning models. So you can use this cloud-based service also to train and deploy, manage your own machine learning models. And this is the life cycle which continues in your machine learning projects. And let's dive into those options. And I will just add a little bit of the examples that what you can also achieve before going to the next slide. So exploring data and preparing it for modeling is one of the examples you can use with Azure Machine Learning. And training and evaluating machine learning models, again, so using your own custom data, registering and managing train modules, deploying train modules for use by any applications and services, and at the end, reviewing and applying responsible AI principles and practices, which is also one of the important topics for Microsoft and also in the world. And it is also taken care also with Microsoft Azure AI services. We can go to the next slide, Said. Thank you. So you can use this link. Actually, this is an exercise from Microsoft Learn. It is based on a GitHub page. You can follow the steps in this exercise to get familiar with the services with the Azure AI and Azure Machine Learning Studio, actually. So touch the services. If you have access to Azure, if you have a subscription, you can already initiate the process and access it. Beside that, if you don't have access, please write in the comments so we can actually know what's the percentage of the people joining in the sessions if they don't have access. But if you are a student, you know that you can sign up for a student subscription and access and get a credit from Microsoft Azure and sign up and use the services, especially in this case, Azure AI Services and Azure Machine Learning Studio. So, Said, is it possible if you go with the portal to show the exercise?
Hamid, I suggest that we can go through these examples at the end of the session, because you can continue with slides, and at the end of the session, because I have to stop this presentation, then I can go through, I walk through these examples in the portal, okay?
Okay, so we do it at the end of the session. Sounds great.
Exactly.
So, but people don't forget to write it down, aka.ms/ai900-auto-ml. So you have, this is public actually. This is not specifically for the people in specific categories. So this is public, you can access it and you can continue this laboratory in your own environment. So let's go for the next slide. Okay. Yeah, now we know we are with fundamentals of Azure AI Services. So everything actually starts with the fundamentals, with basics. I'm not going to dive deep in our previous sessions. We had also with the Azure Zero to Hero and also with Microsoft Learn communities, that everything, again, starts with basics. So take it seriously, understand and comprehend the services in general, and know what it does, how it helps you, how it solves your problem. So what kind of solutions you can generate with those services. So Azure Cloud Platform provides scalable and reliable services, flexible services that you can use to deploy your solutions, deploy your applications. So in this case, we have different data storage, compute services, and other services that you can use within Azure to initiate and implement your Azure AI services. So here in this slide, I'm going to talk a little bit about the Azure structure in general. So we have actually a plan after AI 900 that we will go through AZ 900, which actually dives in the fundamentals of the services for Azure services itself, not just focusing on AI, but also infrastructure, PaaS services, SaaS services, and in general about security and how to implement those services. So wait for the news, and we will also share the news about AZ 900 soon. So in general, in order to have access to Azure, you need to have a subscription. That subscription, you sign up with your information. Again, if you're a student, if you're a professional, so Azure provides, actually Microsoft provides different kind of subscriptions and access to Azure environments. Let's start with the simplest one. So you get into a tenant, you sign up, you have a subscription, you fill in your information, you validate your information, you connect your credit card to the subscription. And then I see in the chat that Bushra says, I can't hear. Can anyone hear me? Just want to verify.
Okay, I think it's a problem with Boschra's system. Yeah, okay.
Okay. Yeah, okay. Just to confirm. Where were we? Yeah. So you get into your subscription, you connect your credit card, and based on secondly, on minute, on hourly and weekly, and you get your invoice at the end of the month for whatever you use within Azure. So within your subscriptions, you have resource group, and within those resource groups, you have resources. So imagine your resource groups as a basket, as a bucket that you keep your resources within it. So, and then you deploy any resources that you want to use. So in this case, if it's Azure Machine Learning Studio services and Azure OpenAI or any Azure AI services that you want to use. If you could go to the next slide. I'm also checking with the time. I guess we need to, but I don't want to miss any of the topics. This is so exciting. So AI services in Microsoft Azure. So as we discussed, so we have Azure Machine Learning, Azure AI Services, and Cognitive Search Services. So let's, for instance, in this course, in the whole course, actually, let's, for instance, imagine we will cover in general, and we will focus in general in those areas of the topics, in those services. So machine learning, AI services, and cognitive search. So Azure AI Vision, for instance, in this case, which we will explain the features of image analysis, face analysis, and optical character recognition. And as a next point, so we will go through Azure AI language, including the information extraction, text summarization, and classification, question answering, and so on. This is exciting. I'm so excited that in the next upcoming sessions that we can go more deep dive in those services. And for the next topic, so each of those services I'm mentioning actually fell in one of those categories we have in this slide. So as a next point, we will go through Azure AI Speech, including text-to-speech and speech-to-text. So that you can use in your environment. So imagine like a translation service. You can talk and it can switch it for you, and based again on your own data. And we will go through Azure OpenAI. And if we get the chance to discover more, it be a bit more in detail, because with the cognitive search, it goes to the next course of the AI with the Microsoft Learn. Then we will be having the chance maybe to discover the cognitive search, and also machine learning, and how the machine learning forms the foundation of the AI's predictive capabilities. So can go for the next slide, say thank you. So in general, once you have access to the environment, it's worth actually a little bit of time to spend and touch the services, break the services in your development environment, not in production environment, especially when it's weekend. Just create services, remove services, upload your own data, play with your own data, try to add some mathematical algorithms, and try to generate machine learning models. In those exercise examples that also mentioned in the previous slides, you can also find some of the machine learning models that you can use in your own environment. So in order to use Azure AI Services, you must actually, for the first time, provision a resource in your Azure subscription. This actually applies to any resources in your environment. But in this case, let's imagine any Azure AI Services. So that can be a standalone or any service-specific resource. Like for instance, just imagine an AI vision resource just mentioned in the previous slide, or a general Azure AI services resources that encapsulates multiple services. So once using those standalone service specific resources, that enables you to manage the costs and access to that service independently of other services you may be using. So while in general, let's imagine Azure AI Service resource that enables you to combine all of your AI services in a single resource, that leads you to have a centralized management environment. So that is actually what makes Azure AI Services unique. So you have a centralized environment for managing all your resources and data. So as you can see, for any AI services, you have a REST API access that you can provide it to your clients, so they can submit their requests and at the end access your AI services. Uh, can we go to next slide, Said? Thank you. Yes, and this is the next slide of the exercise. We have it here. So please also get that link and try to save it. If you are interested, you can just open the link and do the exercise for once. But I would recommend just try to do it for multiple times. So every time you use that same machine learning model, same algorithm to train your machine learning, you will learn more and more every time you generate it. Try it again, try to break it, get some errors, just see, get familiar with it, the kind of the errors you might get actually. So I guess we are the next step could be the questions we have for the knowledge check.
Yeah.
Say, go
So it's
to
time. Before I share the screen, I would like to inform people that if you answer these questions, you will actually be part of our competition in this AI session. So at the end of the last session, which is like next 4 weeks, we are going to give you a badge from Zero to Hero community, and you can share it with your social. So if you want to be part of this party, and also you will get a 50% off Microsoft Exam Fundamentals voucher. So get ready, because I'm going to share this slide and
wow,
we give
amazing,
you.
Said.
Sorry.
Yeah, it's amazing. So with
Yeah,
the
it is amazing.
Microsoft Learn, you will all get Microsoft Learn badge with the specialized code for this course, and you will also get Azure Zero to your badge and also vouchers. That's perfect.
Yeah, it's a one package. So when you're ready, I'm going to share the slide in 1, 2, 3.
So the first question comes with, you want to create a model to predict sales of ice cream. That ice cream sounds familiar from previous slides, based on historic data that includes daily ice cream sales totals and weather measurements. Which Azure service should you use? The first answer we always count as the right answer, isn't it, Said?
Yeah. Yes, yes.
Okay.
Come on, people. Don't hesitate. Answer.
I guess Ji Chen.
Ji Chen. Yes. Ji Chen is the winner in this case.
Yeah, great. Congrats.
Okay.
Let's go to
Second
for,
question.
yeah, Said, you go on for the second.
Yeah, so an automobile dealership wants to use historic car sales data to train a machine learning model. The model should predict the price of a pre owned car based on its makes, model, engine, size, and mileage. What kind of machine learning model should the dealership use automate machine learning to create? So please mention the number of the question and your answer, because then we can easily identify them.
Yeah, that was on your slide. I remember that sounds familiar. So here you
Yeah.
have all the data. So what could be?
So in this case, we have Katerina Samiento, right?
Yeah, I
Yeah,
think so.
yeah,
Correct one.
exactly.
It's a
Congratulations.
regression. Yeah.
Yes. So third one, Hamid, go on.
So let's go with the third question. A predictive app provides audio output for visually impaired users. Which principle of responsible AI is reflected here?
We have these items in
Responsible
the chat.
AI. I see Bushra.
Yeah, Bushra Inayat.
Yeah,
Congratulations. Yeah.
congratulations. It's inclusiveness. So it
Yeah,
comes from
exactly.
responsible AI. Wonderful.
Yeah, so we are going to have the same slides for the next sessions. So don't worry if you couldn't make it now. Of course, you can do it next time. And people that the answer the question, please contact us. You can find us on social media, especially LinkedIn, and we will help you to get those badges, vouchers, and so on.
Yeah,
But the session is not ended, Hamid. We have
yeah.
some other things here, but before that, let's go through the summary that we have had in this session.
Yes. Yeah, as Said mentioned, once you get the badge and also recognitions, try to mention us. So we will be really happy to celebrate it together. All. So what we have covered as a summary in this session. This is just a summary of this session. So we will have a summary of each session in the upcoming weeks. So in general, we learned what is AI, what is AI, and how it works with Microsoft Azure services. So the common AI workloads and the principles of responsible AI we learned in general, and fundamentals of machine learning. So, what is machine learning in general, and what is Azure machine learning in general? Types of machine learnings, model training and validation. What is deep learning? So, we know how deep learning works and how it differs from the actual machine learning, a normal way of the machine learning. So we learned about Azure Machine Learning again and fundamentals of Azure AI Services together with the structure of Azure, how you deploy a resource within a resource group and subscription and tenant and so on. So this is actually the summary.
Yeah. So we have some references here, but the most important part, people in the chat, in the YouTube, in LinkedIn, scan this code and you will get the Microsoft Learn badge. It's the special things that Microsoft Learn shared with you. So for those who are actually be part of these sessions and also next sessions, you can use these badges added to your social medias. Don't forget to scan this QR code, and we will love to see those badges in your social media. Don't forget to mention us, and we would love to be part of this party. And before we finished up the session, Hamid, I'm going to present actually the uh, portal that we
Yes,
promised that we are going to share.
we are
So
missing you, Said. We don't see you on camera.
yes, yes, I know.
Okay. But
I'm
before
trying.
we
Yeah,
go to
I'm
the
trying to
portal,
share my screen.
yeah, it's okay. Before we go to the portal, I just want to mention, well, once you scan that QR code, you will have to log in with your Microsoft Learn account. So you have to have a Microsoft Learn profile. If you don't, then you create it. So if you have already a Microsoft Learn profile account, try to scan and get that badge with the profile that you already have certifications. If you have had exam certifications previously. But yeah, in general, you will need to have a Microsoft Learn profile account.
Yeah. The first part that I would like to share with you, based on those links and slides that Hamid showed you regarding the exercise part. So, there is one part related to Content Safety Studio. So, if you want to learn about Content Safety Studio, go to our YouTube channel. We have had a really amazing session about content safety, which is recorded, like, if I'm not mistaken, 3 weeks ago. And one of our speakers explained the deep side of content safety studio, and you can learn a lot about that. But if I want to show you, basically you need to have Azure subscriptions. This part is a kind of free tier, so you can create and test it. So first of all, you need to create the resource, and then when you got access to it, to content safety, you can test it. So moderate the actually the text, and you can add some text here and see the result in this portal. For example, if I want to show you, sorry about the content that I'm going to share here, but we need to get some understanding. For example, I want to jump from a
Airplane.
rooftop. Maybe, but rooftop. So here, run test. And as you can see, it's self-harm. So AI can understand what is the behind the text that you are going to share. And also you have some basically filters here. You can use these filters and see the result. And it's really great because in some cases you need to go through this content safety, and it's a kind of basic of understanding of the AI when you want to develop the strategy and the AI development and the different services and resources that you are going to have in your environment. The other part that I would like to share with you is related to AI machine learning. This is the AI machine learning studio of Azure. And basically, the first exercise that we're showing you is part of that. So if you haven't access to Azure subscription. So as Hamid mentioned, you can use a student subscription, and also you can have a 1 year free subscription with some limited resources. So you can start testing, and it's like $200, Hamid, if I'm not mistaken, to have as an initial credit to test it out in a way that you want. So I use that exercise, and what you can see here is based on the data that I imported to machine learning, and it's related to bike rental data, and it can predict my data, and I basically can use that to see the result of the some prediction that I would like to have in my environment. We are not going to deep dive into these services because it's a kind of out of the scope of these sessions. But if you want to learn more, check out Microsoft Learn documents, and it will help you to get more understanding. But just so you know that these part of the AI is not part of AI 900 exams that you need to learn about that, but you need to understand what is machine learning and machine learning studio. So yeah, that's all basically. And I think we are kind of done with slides, Hamid.
Wonderful.
Yeah,
Hope you really
amazing.
enjoyed it. Thanks for joining. And we are actually a little bit over time, but
Yeah,
can
and it was
imagine
really
I
great.
really enjoyed it by myself while explaining and learning it again. And you explain and learn from you. That is perfect, and we all learn together. So this is actually the our goal of within the community, within Microsoft Zero to Hero community.
Exactly. If you haven't joined Microsoft Learn yet, aka.ms/join zero to hero. So you are welcome to join us there. And also, I hope to see you all in the next session next week, same day, same time.
Wonderful.